So I know it feels like we've been factoring for about 25 million years. I'm going to show you one more factoring problem just now to show you how we're going to take our solutions and turn them back into our factors. I'm sorry, back into a quadratic. We're going to turn them into factors and then back into a quadratic equation so we can identify from a solution what quadratic equation it goes with. So let's say we have this quadratic equation, x squared minus 3x minus 18. Okay, so, well, I'm sorry, equals 0. So I have this quadratic function, and I want to figure out what its solutions are. So I'm going to factor it. Okay, it doesn't have a GCF, so I have 1x squared here, minus 18. A times c is negative 18. It needs to add up to negative 3. So that means my solutions are, my factors are negative 6 and positive 3. So I have negative 6x, 3x. That means I have x plus 3. X minus 6. So I also know, so now I know that x plus 3, x minus 6 equals 0. And remember the zero product property says that if I have two unknowns that multiply together to get 0, I don't know which one of them was 0, so I have to solve and see what would make that true for either case. So I have x plus 3 equals 0, x minus 6 equals 0. And then, so when I work that out, I have x equals negative 3, and I have x equals 6. So my solution set would be negative 3 and 6. So that's how I go from a quadratic function. I factor, I set the factors equal to 0, and then I get my solution set. Now again, this is set notation. I call it fancy brackets, but what it really means is the set of values that make my equation true. So negative 3 and 6 make this function true. Negative 3 squared is 9, I don't know, I can't do the math right now, I'm sick and tired. But if we were to plug negative 3 and negative 6 into that function, we get 0 for both of them. So this is the set, this is the solution, these are the solutions that make this function true. So we call it a solution set. This is called set notation. It's the same fancy brackets that we use with domain, because the domain is the set of all input or x values that make our situation or equation or function true. And the range is the set of all output values that make our situation or function or equation true. Okay, so now that we've gone this way, we're going to talk about how we would go back. Okay, so what you're going to practice and focus on today is how do I go in the other direction? So instead of starting with a quadratic function and moving to the solutions, I'm going to start with the solutions and move back towards the functions. Okay, so in this case, I'm going to start with my solution set, and it's the same exact problem we just did. So my solutions are negative 3 and 6, so that means I have an x that's negative 3, and I have an x that equals 6. Both of these x values will make whatever quadratic function they go with true. Now, in order for me to turn them back, take them from solutions and turn them into factors, I have to set this equation equal to 0. Well, to get that to 0, I have to 0 out this side of the equal sign, so I have x plus 3 equals 0. I'm going to do the same thing here. I'm going to 0 out that side, and I have x minus 6 equals 0. So now, instead of having these written as solutions, I have them written as factors. So I can take those factors and set them equal to 0. Well, look at this. I got two factors. If I want to find out what quadratic function goes with them, I can just multiply them together. You can do this using FOIL, distribution, whichever method you prefer. I feel like I do my neatest work when I solve with the box, so I'm going to do it with the box. Okay, and then we combine our terms here. So I have x squared minus 3x minus 18 equals 0, which is exactly what we started with here. So literally all we're doing is we're working backwards. So instead of saying, okay, I have this quadratic, I'm going to factor it, set the factors equal to 0, and then figure out what each x is worth, I'm going to start by knowing what each x is worth, setting that equation equal to 0, multiplying the factors together, and getting the quadratic equation they go with. Now, that's an easy one. Let's try another one that's not hard, but it's a little bit more challenging because in this case, I have a fractional solution. So we're going to see what to do with that. We start out the same way. I have two solutions. I know that each of these are my zeros, my x-intercepts, my roots, my solutions. So I'm going to say I have one x that's negative 2/3, and I have another one that equals 6. Both of these x values will make my function true. So now I want to find out, I want to turn these back into factors and figure out what the factors are. So I'm going to add 2/3 to both sides and zero that out. Now I have x plus 2/3 equals 0. Well, that looks kind of crazy. We've never really looked at anything like that. So just like in standard form, how we're not allowed to have fractions, we're going to do the same thing here when we're solving with these solutions. We are not going to have a fractional anything. So if I want to get rid of this fraction, I have to multiply everything by the denominator, which is 3. 3 times x is 3x. 3 times 2/3 is 3 times 2 is 6, divided by 3 is positive 2. 3 times 0 is 0. So there's my factor. Okay? Now, this one's, our usual easy one. X minus 6 equals 0. So now I have my two factors, so I'm going to multiply them together. So I have 3x plus 2 times x minus 6 equals 0. And again, I started with solutions. I converted them into factors, and in this case, I converted it into a factor with no fractions at all, so I rationalized all my fractions. And now I've got two factors. I'm going to multiply them together, okay? And again, I'm a fan of the box method. So I have 3x plus 2x minus 6, 3x squared, 2x, negative 18x, negative 12. When I combine these, I get 3x squared minus 16x minus 12 equals 0, and that is the quadratic function that has negative 2/3 and 6 as my solutions. You're going to practice on this the rest of the day. Any questions that you have, you can ask me, and if you have any more questions, I will talk to you guys about it on Monday. Bye-bye.